Alright dear children, now we solve last numerical problem, that is problem number 7. Now this is a numerical problem which came in ISC 2011, one of the year, okay, and the problem says that in Young's double slit experiment, again we are dealing with the Young's double slit experiment using monochromatic light. Monochromatic light means light of single color, L1 of wavelength, how much? 700 nanometer. So one of the light of wavelength of monochromatic light is how much? 700 nanometer. So what I do, I write down lambda 1. So I write down lambda 1 equals to 700 nanometer. And I will not convert this nanometer into meter because this question is based on again measuring the number of what fringes, okay, in which there are two different wavelengths are given, okay. Now first wavelength is 700 nanometer. So in Young's double slit experiment using monochromatic light, L1 of wavelength 700 nanometer, 10th bright fringe was obtained at a certain point. So 10 bright fringe is obtained at a what point? Certain point. Means the number of bright fringe, the order of bright fringe which is obtained by using this wavelength of light is 10th bright fringe. So for that also I write down M1. So M1 is what? 10. So M1 is what? 10. So the bright fringe which is formed with this wavelength of light is 10 bright fringe, which is M1 is 10. Was obtained at a certain point P on a screen. Now question say that which bright fringe means you have to find again the number of bright fringes, okay, the order of bright fringes will be obtained at the same point. Again the next bright fringe which is obtained on the same point if the monochromatic light of wavelength 500 nanometer is used. Now in place of L1. So if you replace instead of L1 lambda 1, sorry, that is 700 nanometer, if we use a wavelength 500 nanometer, so for that I'll write lambda 2, and that is 500 nanometer. Okay, so if we use 500 nanometer instead of 700 nanometer, in which particular bright fringe, which particular order of bright fringe will obtain on the same point P on the screen, that order of bright fringe we have to find out. So that order can be calculated as M2. So I am writing M2 be the order of what? Bright fringe. Order of bright fringe, okay, formed at P using wavelength of light, how much? Using wavelength of light, and that is how much? 500 nanometer. So in order to solve this question, we have to find the order of bright fringe, okay, but for first wavelength 700 nanometer the order is 10. If you go to what? 10th bright fringe. Now with 500 nanometer, which bright fringe will form on the same point, that we need to find out. And children, we are dealing out here with the bright fringes. So there is a formula, you know it, that the position, I write down the position of what? The position of mth order. Mth what order? What fringe? Sorry, this is bright fringe. Mth order bright fringe is given by x equals to m lambda d by d. Yes, this is the formula, you have done it. X equals to m lambda d by what? D. Where m starting from what? 0, 1, 2, 3, like that and on. So if m is 0 means that is for central bright. Okay, m is 1 means first bright. Now what I do, I just cross multiply. And make m lambda as the subject. So it will be xd equals to m lambda by d, m lambda d. So I write down xd by d, capital D equals to m lambda. See, xd by d equals to m lambda. Okay. Now the interesting part in this question is we have to find the order of bright fringe at the same point. At the what point? Same point. So for the same point in which the bright fringes are formed, x, the distance of that bright fringe from the central fringe must be same. So x must remain constant. If x is constant, d by capital D are also constant. The distance also not changing. Slit width, screen distance is also not changing. This is constant. X is also constant for the same point on the screen. So means this factor remain constant. That means the factor on the left hand side remain constant. If this quantity of left hand side is constant, means the right hand side is also constant. So I mean, I don't m lambda is also what? Constant. So if product of m and lambda is constant, means yes, I follow this way. M1 lambda 1 it must be equals to M2 what? Lambda 2. So if m lambda is constant, then M1 lambda 1 is equals to M2 lambda 2. Now from here only I can calculate the value of M2. So I calculate what? M2. Because M2 means the order of the bright things with the wavelength of light what? Lambda 2. Okay, so we need to find M2. So M2 will be equals to M1 lambda 1 by lambda 2. So this formula we use this formula to calculate the order of bright things. Now let's substitute the value. M is how much? 10. Lambda 1 is how much? 700 nanometer. And lambda 2 is how much? 500 nanometer. So this 0 0 cancel out. 5 1s are 5, 5 2s are 10. Unit also cancel out. So it will be 2 into 7 means 14. So M2 is 14. Means which order bright rings will form on the same point on the screen P when you use a wavelength of light 500 nanometer in place of 700 nanometer, 14 bright rings. Which order of bright rings? 14 bright rings will form.